Number patterns, complex procedures. Okay, this is the second test for the chapter number patterns that we're working again, 50 marks. And we're going to start with the first question. There's 6 of them, from about 2 to 8 marks each. All right, so the first question, this is now more complex questions, and this is more of typical things that you can expect in exams. Says an arithmetic series has 10 terms. The sum of the first 3 terms of the series is 18, while the sum of the last 3 terms is 81. Find the sum of all 10 terms. Right, now first I'm working with an arithmetic series. An arithmetic series has 10 terms with 10 terms, right? This is important information. The sum of the first 3 terms is in the series is 18. So the sum of the first 3 terms, the first term is A, the second term is arithmetic, so I add a constant D. The second one will be A plus D, and the third term will be A plus D, so plus 2 Ds. All right, now the sum of the first 3 terms is 18, while the sum of the last 3 terms is 81. So the last term will be A plus, and now I have, I'm just going to quickly write that for you here. My general term will be A plus n minus 1d, right? So the 10th term will be 10 minus 1 will be A plus 9d. My 9th term will be A plus 9 minus 1, 8d, and my 8th term is, this is the last 3 terms, will be A plus 7d, just so you can see where I'm coming from with this. So my 10th term will be A plus 9d, the sum of the last 3 terms. So A plus 9d is my 10th term, my 9th term is A plus 8d, and A plus 7d is my 8th term, and the sum of the last 3 terms is 81. So if I add the last 3 terms, I will have 81. From this information, I must now find the sum of all 10 terms. Now, if you are somebody who tends to get lost in procedure, what I must do at the end is I must find the sum of 10 terms, which is 10 over 2 times 2a plus n minus 1d. If you're somebody who gets lost in procedure, just write that down here for yourself. Alright, so this is a plus a plus a. There's 3 a's and a d plus 2d. There's 3 d's is 18. And this means if I divide by 3 throughout, that a plus d must be 6. Okay, there's nothing much I can do with that. Let's look at this. There's a plus a, so there's also 3 a's. There's a 9d plus 8d plus 7d. This is 24 d's. Should be equal to 81. And then I can also divide all these numbers by 3 just to simplify it a little bit. And 81 divided by 3 is 27. Right, now I've got 2 equations here, and I want to find the a and the d values so that I can work with that here at the end. And I've got 2 equations here with an a and a d. Can you see clearly what you must do is I must solve simultaneously for these 2 equations. Okay, so in this equation, I get one of the 2 alone, so I have a is 6 minus d. And that I'm going to substitute into this equation. So a is 6 minus d plus 8d is 27. Then 8d minus d is 7d, and 26 minus 6 is 21. So 7d is 21, that means d is 3. And that I can substitute back there. So a is 6 minus d, which is 3. So a is also 3. Right, so now I've got the values for a and d is both 3, and what I asked in the question is I must find the sum of the first 10 questions. This question, by the way, counts 8 marks. Okay, so it is a lot of work, but it counts 8 marks. All right, and then I've got 10 over 2 is 5 times 2a, which is 3, plus 9d is also 3, and now it's quite a simple equation. You can really just enter this into your calculator. But this is 6 plus 27 is 33. Okay, so it's 5 times 33. I think I'm just going to grab my calculator. 5 times 2 times 3 is 6, plus 9 times 3 is 27, and that gives me 165. All right. So that's the first question. Done and dusted. Just see how we use the information you know from the things that you know. You know that the arithmetic pattern goes a plus d, a plus 2d, up until a plus 7d, a plus 8d, a plus 9d, things like that. And then I just literally take the information that they give to me in the question and I just write that down and simplify. And as far as I simplify, I actually solve the question. So it looks like a crazy question, but if you just keep calm and just translate what they say into mathematics, then it gets obvious at some point what you must do. And then just the question says find the sum of all 10 terms, and I know I work with arithmetic, so I write the formula for arithmetic sums is n over 2a plus n minus 1d. I write all of the knowledge that I have down, and then from there on I just substitute and simplify. So it looks complicated, but really not that bad. Okay, the second question is for 4 marks. It says the sides of an equilateral triangle are 100 centimeters each. Now, if they give me something like this, I like to just go and draw up a picture. This is an equilateral triangle, and every side is equal to 100 centimeters. The sides of an equilateral triangle are 100 centimeters each. The midpoints of the sides are joined. So the midpoints are joined. To form a new equilateral triangle. Now this equilateral triangle, can you see, will be 50, 50, 50, 50, 50, 50. So the new equilateral triangle will have side lengths 50 centimeters. If I join the midpoints, then that's 50, 50, and then this is also 50. This process continues indefinitely. Calculate the sum of the perimeters of this indefinite series. Okay, okay, so if I do this again, the new side lengths will be Z will be 25 centimeters. Okay, now they say this process continues now, so I make it smaller, 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 smaller. Calculate the sum of the perimeters. So my first term will be 100 plus 100 plus 100 will be 300. My second term is the sum of the triangles will be 50 plus 50 plus 50, which is 150. My third term will be 25 plus 25 plus 25, 3 times 25, which is 75. Right, so I can see I've got a pattern 300, 150, 75, 300, 150, 75, and what's happening? I've got a pattern with my first value 300. This is the things I'm interested in. My first value is 300, and then can you see it's times a half, times a half, times a half, times a half. So this is a geometric pattern with my R value of half. 150 over 300 is a half. 75 over 150 is a half. So this is a geometric pattern. And now I want this sum to infinity of these numbers. Now that's not difficult. The sum to infinity is if my R value lies between -1 and 1, which it does. Let's just state that this is a convergent series, so I can go and calculate the sum to infinity. Is A over 1 minus R. I've got A, I've got R. This is very easy. Right, so my A value is 300. My R value is a half. And this is 300 divided by a half, or 300 times 2. Which is 600, and this is in centimeters, so my perimeter will also be in centimeters. Okay, so that is the second question. The third question consists of two parts. It is 3.1 and 3.2. 3.1 is for 6 marks and 3.2 is for 3 marks. 3.1 says, let me just write down this pattern here first for you guys. X squared minus 3 squared plus, looks like this. Says, for which values of x will the infinite geometric series this be convergent? Alright, now for convergent, I know my R value must lie between -1 and 1. My R value I can calculate by taking a term divided by the term before that. So I can take this divided by that, or this divided by that. This seems easier because it's over 1. So I can take x squared minus 3 over 1 must lie between -1 and 1. Okay, I'm going to break this up into two problems. I'm going to evaluate where is x squared minus 3 bigger than -1, which is that side, and also where is x squared minus 3 smaller than 1. So bigger than -1 and smaller than 1. For this side, I've got x squared minus 2 is bigger than 0. So I just took over the -1. -3 plus 1 is -2. And then this is difference of squares. 2 is not a perfect square, but I'm just going to force it a little bit by making the root of 2 like that. So x minus root 2, x plus root 2 must be bigger than 0. Right. This is a parabola. Which looks like this. So bigger than 0. Actually not like that exactly, sorry. Which looks like this. Bigger than 0 will be that bit and that bit. These two values is root 2 and negative root 2. So this is negative root 2. This is root 2, can you see? So that bit will be where x is smaller than negative root 2. And this bit will be where x is bigger than root 2. Okay, so I've got that from this. From this side, I've got x squared. I'm going to take the 1 over also. So it's x squared minus 4 is smaller than 0. Then x minus 2, x plus 2, difference of squares, is smaller than 0, meaning x must lie. This is also parabola. X squared minus 4 going through the x-axis at -2 and 2. Can you see? There is one x value, is one root or one x value where y is 0. One x value lies at 2, 2 minus 2, and minus 2 plus 2. So then the other x value lies at 2. So this is smaller than 0 between minus 2 and 2. Can you see? So where x lies between minus 2 and 2. Right, now both these things must be true. Right, because this equation lies between that. So I took them separately, but both these things must be true. So I'm just going to evaluate where both these things are now true. If I have on a number line, I'm just going to place minus 2 and 2. X lies between minus 2 and 2. X lies here somewhere, right? And now I've got a pen that doesn't want to write. Let me just see if I can get one that writes. That's better, okay. So for this, x lies between minus 2 and 2. And for these limitations, I've got there's 0 minus root 2. Now root 2 will be smaller than 2. So minus root 2 will lie between 0 and minus 2. And root 2 will lie between 0 and 2 somewhere, right? So x must be smaller than root 2. That means for this bit, x must fall there, smaller than root 2. So in that area, I know this is my area from this. But from this, x must lie smaller than root 2 or bigger than minus 2. So can you see the places where x is valid for both things is this bit there and this bit there. Right. So that's actually not going to work because it doesn't work for that limitations. Right. So I can say from this, if I look at the number line, I can say that x must lie between minus 2 and minus root 2, or x can lie between, let me just shift this up a little bit, x can lie between root 2 and 2. Right, so there's these two things combined then, and that will be my final answer. Now for 3.2, this counts 6 marks. Right, 3.2 counts 3 marks. They say calculate the sum to infinity if x is 1.5. The sum to infinity if x is 1.5. Now I know if x is 1.5, it lies there. So if x is 1.5, this is a convergent series. That's what I've worked out now. This is convergent for the x values that lies there. So if x is 1.5, my r value is x squared minus 3. X is 1.5 or 3 over 2. X squared minus 3 is my r value. Let me just quickly go and work out my r value. So I'm going to use my calculator. 3 over 2 squared. Just for safety, I'm going to put the 3 over 2 in brackets actually. 3 over 2 squared minus 3. That means my r value is negative 3 over 4. Perfect. It lies in this area where it should lie. So my r value is negative 3 over 4, and then my a value is the first term is that 1. So the sum to infinity will be a over 1 minus r, like that. And then my a is 1, and my r value is minus 3 over 4, like that. Okay, and I can literally just substitute that into my calculator. So I've got a fraction 1 over 1 minus, the previous answer was minus 3 over 4, and that gives me 4 over 7. Or you can just, if you don't trust that function, you can just substitute minus 3 over 4 there also, exactly like that, and that gives me 4 over 7, so that's the sum to infinity. Right, question 4. Yet again, I've said this quite a few times, but it might be a good idea when we work out problems. Might be a good idea for you to write down the problems as I go through them. Make sure you understand them and then try and do them on your own first. And then if you've done them on your own, play the video. Pause the video, write down the problem, pause the video, try to do it on your own, and then play the video and see and compare your answer with mine. Alright, so for question 4, they say 3 numbers form an arithmetic sequence. So I've got a sequence with only term 1, term 2, and term 3. 3 numbers form an arithmetic sequence. Be sure to know what type of sequence you're working with, because the formulas that we use depends on what type of sequence we work with. Their sum is 24. So if I add these, that gives me 24. Then they say for 4.1, if A is the first term and D is the common difference, show that A plus D should be 8. Now, if A is the first term and the common difference is D, then my second term should be A plus D. My third term should be A plus 2D. This gives me 24. Show that A plus D is 8. Okay, let's simplify this. I've got 3 A's. Horrible. I've got 3 A's and I've got a D and 2 D's, so I've also got 3 D's is 24, and then I can divide throughout by 3, so A plus D is 24 divided by 3 is 8. This is what I must show, so good. Okay, this counts 2 marks. 4.2 counts 8 marks. So here comes a horrific question again. They say, if the first number is decreased by 1 and the second number is decreased by 2, the 3 numbers then form a geometric sequence. Find the numbers. So if I take term 1 and I subtract 1, if the first number is decreased by 1 and the second number is decreased by 2, the 3 numbers then form a geometric sequence. Okay, I've got the information that A plus D is 8. My arithmetic term, I can write as A plus D, and A plus 2D. But now I've got a feeling that they let me work this out so that I can substitute maybe D is 8 minus A, so that I write this only in terms of A, because two variables always complicates things. So let me rewrite this as A plus D, which is A plus 8 minus A, and this is A plus 2 times D, which is 8 minus A. Then this term looks like this. I know this second term is 8, and this is 16 minus 2A, so 16 minus A. A minus 2A is minus A, and 2 times 8 is 16. So this term looks, the sequence now looks like this, only in terms of A. Then my geometric one that they give me, geometric, they say if I subtract 1 from there, and I subtract 2 from there, so then this is 6, 16 minus A. Then this is a geometric series. Now, if it's geometric, then I know that my second term over my first term should be the same as my third term over my second term. And I can cross multiply. 6 times 6 is 36, should be equal to A minus 1 times 16 minus A. the reason I'm doing this is if I can work out the value of A, I have these, if this is now expressed only in terms of A, so if I can somehow work out the value of A, then I can find the terms. Right, so I wonder if it's not going to be easier to say 8 minus A is equal to 16 minus A minus 8. Oh, both of that gives me 8 minus A. So I still just have my difference is 8 minus A. I can't work from that, my A. So from the geometric series, let's see if we can find A. Multiply this out. I've got 16A minus A squared plus A minus 16. Like that, this is 36. I'm just going to continue there on that side. Let me just move up a little bit to this side. Okay, right, so I'm going to take over all of the terms to one side. So if the A goes over, it becomes A squared. If this is 16A plus A, so it's 17A, becoming negative 17A on the other side. And then 36 plus 16 is 52. Plus 52 is equal to 0. All right, let me see if I can maybe factorize this. 52 divided by 2 is 26 plus 2 is not going to work. Let me see if I can divide this by 4, 13. Yes. Okay. So 52 is 13 times 4, and 13 plus 4 gives me 17. So I have that A is equal to 13 or A is equal to 4. Now I've got two values, meaning for my arithmetic sequence, if I substitute A13 in there, I'm going to generate two sequences. For my arithmetic series, if I substitute 13, I've got 13, 8, 13, 8, and 16 minus 13 is 3. 13, 8, 3, like that. Or if I substitute 4 in there, I can generate the series 4, 8, and 12. Can you see? 4, 8, and 16 minus 4 is 12. So I can have 13, 8, 3, or I can have 4, 8, 12, like that as my series. For my geometric series, I can also generate 2. They said find the terms, so I'm finding the terms for arithmetic and geometric. If I have 13, I've got 13 minus 1 is 12, 6, and 16 minus 13 is 3, which means it's a geometric series divided by 2 divided by 2. Or if I substitute 4 in there, I've got 4 minus 1 is 3, 6, and 16 minus 4 is 12. So this will also work, right? So for my geometric series, it could be divided by 2, or times 2 times 2, but my series is going to start either 12, 6, 3, or 3, 6, 12, and I can generate two series that will satisfy all of this information. All right, so that is question 4. This second one is 8 marks. I know it seems like a bit of a crazy crazy question, but if you just stick with it and just do step by step, translate into mathematics, just simplify, solve as much as you can. It takes a bit of practice to get to the point where you can just solve it. But just translate into mathematics what they say in words, simplify as far as you can, solve, go reread the question every time. If you think, okay, now I've done something, what am I doing here? Every time you think, what am I doing here, just go reread the question over and over again, and that way you train your brain to think about the process that you're doing there, and it gives you the stamina to go through long problems like this if you reread the question the whole time. And the further you go through the question and you get towards the answer, the better your stamina becomes also to finish long problems like that. Okay, question 5 says, the following sequence is a combination of an arithmetic and a geometric sequence. Oh boy. Okay, they give me this 3, 3, 9, 6, 15, 12. Like this. Okay, the following sequence is a combination of an arithmetic and a geometric sequence. They give me this. Study the sequence and then use it to answer the questions that follow. Right, so study this pattern. 3, 3, 9, 6, 15, 12. Study it for a while. See if you can figure out what's going on here. I'm just going to write it down a little bit lower. 3, 3, 9, 6. Again, pause the video, write it down, pause the video, see if you can figure out what's going on here. Okay, on your own. Now, if you pause the video, hopefully you saw that there I go. If I go from 3 to 9, 9 to 15, 15 to, I go times, no, not times 3, plus 6, plus 6. So there I will go plus 6 and 15 plus 6 should give me 21. And if I look at the other numbers, what's happening there is I've got times 2, times 2, times 2, which is 24, like that. Can you see that's what's happening here? Okay, and there the even numbers, the even terms like term 2, term 4, term 6. So the even terms is a geometric series, geometric sequence actually, with A3 and R2. Can you see? And the uneven terms, term 1, term 3, the uneven terms is an arithmetic series. With my first term also 3 and my common difference 6. So this is what's happening there. Right, now I can look at the questions quickly. The first question is for 2 marks, 5.1, and says write down the next 2 terms in this sequence. Okay, now I've already written them down there, but you can just write them there, 21, 24. And then 5.2 for 6 marks says work out the value for term 22 minus term 21. Work out the value for term 22 minus term 21. Right, now term 22 is an even term, and that will be the term 22 will actually be the 11th term. I'm just going to make that a small t. Will actually be the 11th term in the geometric series a r to the power of n minus 1 with a3, r2, and 11 minus 1 like that. So that is 3 times 2 to the power of 10 to the power of 10, which is 3072. And the 21st term, now I must just think clearly here. The first term is term 1, the first term of the uneven arithmetic series. The first term in my big series is term 1 in the small one. The third term is term 2. The fifth term is term 3. So what's happening is, if I times this with 2, I must subtract 1. No. How am I going to do this? Yes. If I take this term number here and I multiply it with 2, I must subtract 1 to get that. So here 1 times 2 minus 1. So it's 2n minus 1 actually. 2 times 3 is 6 minus 1 gives me 5. So 2n minus 1 is term 21 is then term 11 also, the 11th term of this, because 22 minus 1, yes. Right, so in this pattern, in the big pattern, term 21 is also the 11th term in the arithmetic series. Right, so the 21st term is term 11 in the arithmetic series, a plus n minus 1d, where my a value is 3, the 11th term, and my d value is 6. So this is 3 plus 10 minus 6 is 60, plus 3 is 63. Oh, I don't know what's going on outside here now. Sorry about that. Right, so term 22 is 3072 minus term 21 is 63. And then I can just quickly, I think it's 3009, but let me just make sure. Yeah, that would then be 3009. Alright, so that's question 5.2 for 6 marks. I suppose probably the marks will be allocated 2 marks for calculating term 22, 2 marks for correctly calculating term 21, and then 2 marks for subtracting that 6 marks like that. Okay, then question 5.3 is proof that all the numbers in this sequence are divisible by 3. Right, now my even terms is geometric series. My geometric series, all of the even terms, follow the, I'm just going to use small t's for this, follow the rule a r to the power of n minus 1, where my a value is 3 and my r value is 2 times n minus 1, but doesn't matter what I make the n's. Can you see that all of these terms are divisible by 3? All divisible by 3. And my arithmetic series, because it's a product of 3, my arithmetic series, let's see if I can just write this as a product of 3 also, will be a plus n minus 1d, where my a is 3 and n minus 1 times 6, my d value is 6. So if I simplify this a bit, this is 6n minus 6n, and this is minus 6, so 3 minus 6 is minus 3, and then I can write this as a product of 3, which is 2 times n. 3 times 2n gives me 6n. I actually just take out the common factor 3. So then this is clearly also a product of 3. So this is also all divisible by 3. Divisible by 3. Okay. And question 5.3 counts 4 marks, I guess, for my geometric series with the conclusion, and for my arithmetic series with the conclusion 4 marks then. Right, last question for 7 marks. Question 6. Last question for this test, question 6. Right, I've got, let me just write down this monstrosity here first. And then I'll read you the question. 2 over 5 times 2 2b minus 1, like that. Okay, this is what they give me there. They say, what is the least value of n for which this sum will be bigger than 11,000? Right, the least value of n. So if I can see this is a geometric series. I'm not sure about the a and the r values, because my geometric series looks like this: a times r times n minus 1. Now there's an n which is 2p, which is not normal. So I'm maybe just going to write out here first for myself term 1. If I make p1, this will be, I'm just going to substitute that into the calculator, 2 over 5 to the power of 2 times p minus 1. Okay, I've got the formula there where p is supposed to be. All that I really did is I just made brackets. So now for p1, I'm going to substitute in the brackets there 1, and that gives me 4 over 5. For term 2, I'm just going to substitute in that place of the 1. I'm going to substitute 2. Oh, this dogs is really a bit of a problem now. 16 over 5. Sorry for the distraction. Term 3. I'm just going to substitute in the place of the 2 there a 3. And that gives me 64 over 5. Okay, and then if I write down this series 4 over 5, 16 over 5, 64 over 5, I can clearly see that this is a geometric pattern with the a value. The first term is 4 over 5, actually not 2 over 5 as it seems there. And with the r value, you can just take 16 over 5 divided by 4 over 5 on your calculator, or you can maybe see that it's times 4 times 4 times 4. Just to test, I can just make sure 16 over 5 divided by 4 over 5, just make sure, but that gives me 4. Right, So this is a geometric pattern that looks like this. What do they want to know? The least value for this pattern that is bigger than 11,000. So the sum of a geometric pattern is a r to the power of n minus 1 over r minus 1, right? And I want this to be bigger than 11,000 if I add this up. Okay, so my a value is 4 over 5. My r value is 4 to the power of n minus 1 over r is still 4 minus 1 is bigger than 11,000. I'm just going to continue here on this side. Oh, sorry. Okay, sorry about that. Okay, so I've got this, must be bigger than 11,000. So I can take this, this is 3. I'm just going to write that over there. 4 over 5 times 4 to the power of n minus 1 over 3 must be bigger than 11,000. So I multiply by 3 both sides, so 4 over 5 times 4 to the power of n minus 1 should be bigger than 33,000. Then I can divide by 4 over 5, so 4 to the power of n minus 1 should be bigger than 33,000. Oops, that's one too many. 33,000 divided by 4 over 5. That is 41250. So then 4 to the power of n should be bigger than 41251 if I add that one. And now I'm going to use logs. Log with a n should then be, I'm just going to find an estimated value for n first. If 4 to the power of n is equal to 41251, what's happening? I can see my number grows bigger, so I've got an idea as n goes on, the number is bigger, so I must just take the next n to make it bigger. N is then log with a base of 4, 41251, or it is log of 41251 over log of 4, and that gives me 7.666070. Okay, what an evil number. Okay, so it gives me this. Right, now this means actually if n is 7, it's just this means for the 7.666070 term, my sum is exactly 11,000. So if n is 7, it's going to be a bit below 11,000. So the smallest term where it's going to be above 11 will be for term 8, will be bigger than 11,000, and that's the first term that's bigger than 11,000. Alright, so term 8 for N8. Okay, this is for 7 marks. Right, so this is the complex procedures and problem solving test for 50 marks. And then in the next video, I'm going to do also complex questions, which is similar to exam type questions.